All right, let's take a look at ionic compounds. So we have metal plus nonmetal, but this time it includes a transition metal. So remember, when it doesn't include a transition metal, we know what the charge of the cation is. So for example, here we know that everything in row 1 is going to be +1. Everything in row 2 is going to be +2. And things in row 3, especially aluminum, are going to be +3. The rest of them, I would say most of the time they're +3, but there are some exceptions. And then we have our transition metals, and these transition metals can be of a varied charge. Note that I didn't highlight silver and zinc. We'll learn about those in a minute. They're a bit of exceptions to this rule, but basically transition metals that we've highlighted here in green, they always have a positive charge. Well, almost always have a positive charge, but that charge is variable. So these transition metals can exist as different charges. Sometimes they're +1, sometimes they're +2, sometimes they're +3. They can go all the way up to +7. +7 is the most I've seen. And so how do we know the charge of our metals if they can be variable? So what we have to do is we have to take a look at the formula of the compound. So for example, CuCl2, the first thing that we note is that all of these compounds have no net charge. Right, the overall molecule or the compound is neutral. So their charges have to sum up and cancel out with one another. And then if we think about chlorine, if we find that on our periodic table, that's a halogen. And we know that halogens prefer to have a -1 charge. And so this halogen, this chlorine, is indeed going to be -1. And then there's 2 of them for a total charge of -2. And then if we think about what the copper has to be, in order for it to be totally neutral, this has to be a copper 2+. But like I said, you can have these transition metals in different charges. So for example, CuCl3 is another form of copper chloride. And in this case, we have 3 -1s. So to balance that out, this copper must be a +3. So those are overall pretty simple examples, but they can get a little bit more complicated. So for example, iron oxide comes in many different forms. One of the forms is Fe2O3. And so we want to know the charge of the iron in this iron oxide. So we know from our periodic table that oxygen, it's right over here, that's going to have a -2 charge. So each one of these oxygens has a -2 charge, and there's 3 of them for a total of a -6. Again, we know that the overall charge of the compound is 0, so the charge of the iron must cancel this out. If we think about it, there's 2 irons, and then what we want to calculate is our charge, so we'll call that our X. So we have 2x minus 6 equals 0, and then you can do the math there yourself. You'll end up with a +3. So in this case, this is an iron 3+ ion, but it can be all kinds of different things. Another example is iron nitride, which may or may not look like this formula. There's many forms of iron nitride. If we think about nitrogen, it's located right there. That has a -3 charge. And there's 4 of them for a total of -12. If we think about the iron side, that has to cancel out that negative charge. So that iron has to be a total charge of +12. But of course, there's 3 of them. And so if you solve the equation, right, add these up, set them equal to 0, you're going to end up with an X is equal to 4+. So in this case, this is an iron 4+. So while transition metals have variable charge, if we have the formula, we can calculate the charge of our transition metal by looking at what the charge of the anion is and then balancing out the equation.